Hi everyone. We'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valan Kolika and I'll be your host for today. A few reminders before starting. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of the Teams, please exit and rejoin. Please note that this webinar is being recorded and it will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. During this time, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on Microsoft Threat Protection forum at aka.ms/mtptc. Now, all the links that I'm calling them out, I have also posted them on the Q&A channel, so you'll be able to reference to them. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars. You can do so at aka.ms/security-webinar-feedback. And while you're there, please join our community by visiting aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for that at aka.ms/security-private preview. And while you're there, you can request features. You can give feedback, review our product roadmaps, attend in-person events, hopefully that's coming soon, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. Today, we're kicking off the Advanced Hunting series with MTP, Microsoft Threat Protection. Michael Malone will take us through the basics of advanced hunting and cover the KQL basic using MTP. Michael is a principal program manager with our Microsoft Threat Protection team. And without further ado, I'll turn it over to him. Michael, the floor is yours.
Absolutely, thank you, Valan. So, as mentioned, my name is Mike Malone. So I'm with the Defender ATP team, and we're here to talk about Kql query language. So this is definitely a deep dive. So we're going to start at the beginnings of KQL and work our ways from initially learning the fundamentals of the language and the schema and data inside MTP's advanced hunting, then move forward to more advanced topics, all the way up to going through and triaging an incident using primarily advanced hunting. So to introduce you to this series, along with the video series, we are going to provide query files. So you can access the query files at aka.ms/trackingtheadversary. So this is available. This is published on our GitHub. If you check it just before one of the episodes, you should see a .csl file, which is going to contain all the queries we used in this particular episode. So this is going to be KQL Fundamentals. We're going to start talking about the core operators inside KQL. What is Kql language in general? We're going to move on next week into join, so talking about how to join different data sets. The third episode, which is the week afterwards, is going to be how to summarize, pivot, and visualize the data. So we'll be getting into how to make it look nice, how to make it good for a report, and how to make it actionable when you have thousands and thousands of rows that come back from advanced hunting. And then on our last episode, we're going to be actually taking you through a incident hunt, if you will. So we're going to be tracking an adversary through an MTP incident and looking at different techniques you could use inside advanced hunting to find embedded attackers within an enterprise. So I'm going to switch over, as I promised. There's no slides for the majority of this presentation. I do want to call out a couple of really important links. So there's the language reference. So this is if you want to learn about the Kql language itself, which is the underlying language behind a lot of our products. So MDATP Advanced Hunting, MTP Advanced Hunting, Log Analytics. There's also the MCAS Advanced. There's a bunch of different places, as well as you've got. There's also Azure Data Explorer, which is if you want to run your own Kql cluster. This is the language reference for KQL. There's also the specific implementation that we use here in MTP. So the advanced hunting reference is going to walk you through how the tables are structured, the different types of fields and capabilities. And there's also a schema reference, which we'll go into in a later episode. So let's go ahead and get started and let's talk about KQL. So what is KQL or Azure Data Explorer? So it's a write once, read many data set that's used in a variety of products we just mentioned. It's tuned to work with log data. So it's designed so that you can constantly keep appending, and the query is focused on the fact that you can insert a row and you can be confident that that row is not going to change between when you insert it and when it eventually leaves the system. It is a case-sensitive language, so there is case-insensitive operators, but when you're actually using the query commands, they are case-sensitive. For example, if I was to change that print in the first line here to a capital P, this would no longer work. So when you are using this, be sure to keep everything case-sensitive. This includes column names and variables. It also has the ability to automatically expire records based on a specified interval up to 10 years. Now, inside Microsoft Threat Protection, the retention of the data is going to be defined at the moment by the individual product retentions you have for everything involved in MTP. So MTP is basically combining Defender ATP, MCAS, Azure ATP, and Office ATP. So for example, in Defender ATP, when you stand up your instance, you have the option to configure its retention up to 180 days. That could be configured after the fact if you'd like. It's also worth noting that there is a hot and cold interval in here as well. So when you're querying your data sets, the more recent data is going to come back faster. So the best way, if you run into a performance issue, is try to reduce the time frame. If I was to provide a recommendation, if possible, unless you need more data to build the picture, try to keep it around 7 days. Now, this little option here in the upper right is going to be where you're able to choose if you want to do 24 hours, 7 days, 30 days, or a custom range. Or as you'll see, you can also specify a lot of date-based filters inside the query language itself. You also want to try, if possible, to reduce the data earlier in the query before doing your joins and manipulations. This is just to make sure that you're not pivoting and summarizing and calculating on data that you're ultimately going to just eliminate. This is going to ensure you have your best performance with Defender with Microsoft Threat Protection Advanced Hunting. So let's talk a little bit about the query format itself. So it starts out with the data source. This data source can be a variable, it can be a table, it could be a function. There's a bunch of different types of data sources available in KQL. Most of the time, you're going to be using a table. So you have your tables over here on the left. They're grouped based on what type of data they're looking at. So, for example, email is going to be primarily your Azure, your Office ATP data. Apps and identity is going to be MCAS data, and device data is going to be from Defender ATP. You're then going to feed that into a bunch of filters, modifiers, or limiters. And the way you do this, the way you separate your statements, is with a pipe. So for example, if we start out with device process events, we use take 100. So the device process events table to get started is going to be it's going to be a list of all process creations that happen on a device that's monitored by Defender ATP. So when this comes back here, there we go. So what you're going to see in here is you'll have the device that the process was launched on. You'll have the identity that launched the process. You'll also have a bunch of great information about the file hash that was used to create the process, the command line that was used to create the process, as well as the process which created the process and the identity of that process as well. So you'll see, for example, here we've got initiating process, account domain, and account name. This is essentially the user account of the process which launched the process we're looking over here on the left. So if you're ever trying to find out every process that was launched by cmd.exe, you can do that by searching on the initiating process information, or you can see the individual CMD calls if you search for it under the process command line. So the first operator we're going to talk about is really important for testing. So take is going to return a sort of a random number. So it's going to be, in this case, 100 rows. It's going to be a sort of a random gather from your query, though. So in other words, don't expect this one to be ordered necessarily. This is great for testing, though. So for example, if I just ran this without this take 100, I'm going to get every single row back that's in the device process events table. Now, this is also a good time to talk about the limitations from a rows perspective. So when you're hunting in MTP Advanced Hunting in the web interface, you're going to be limited to 10,000 results in your query. You can also download those query results here using the export button. They are paginated as well, so you can actually specify how many items you want per page. But if you want to get more out of it, there's a couple of tricks you can do. Either one's like partitioning, where you slice the data up into smaller chunks, but perhaps a better way, if you plan on running this query periodically, there's in many cases advanced hunting APIs. So like, for example, the Defender ATP advanced hunting API will let you bring back up to 100,000 rows during a query. So that may be something to consider if you're running a device-based query that's going to bring back a lot of rows. If you are a SQL person, so for the first episode especially, if you're a SQL person, I'm going to try and liken it to how it would work in the SQL world. Essentially, this is like saying select top, in this case it'd actually be 100, so it'd take 100, I believe, up here, star from device process events. Give me everything, every column for the device process events, but only give me 100, and technically you'd have to specify, sort of an order down here. So as I mentioned, a data source can be a table, a function, or a variable. So in this case here, I'm going to create a new variable called foo, and I'm going to set to the value bar. Now, this is going to use a very handy little operator called let. So let is going to define a variable. It's only defined for this particular query, though. So this is not something that sticks in the session. You're going to have to define this again and again once for each of your queries. So the let statement can be used to store scalar values, which this is a scalar value. It's a single column that comes back, single row, single column. You can bring back tabular, basically like a table. So if you want to store the results of one query and then use it again and again inside your bigger query, you can store a table. You can also store functions, which is kind of handy. So if this enables you to pass, you can actually pass variables into the defined variable. Or there's also what are called dynamics. Now we'll talk about dynamics a lot later on, but essentially a dynamic is a JSON field that can use dotted notation to navigate through the object model. Now, this anybody who's done some software development knows the pains of the semicolon. So yes, you have to have a semicolon to let the query language know that that's the end of the variable definition and the beginning of either the next variable or perhaps the query itself. The next one down here is print. So print is also what I used at the very beginning of the presentation. It's designed to just output a single scalar value. So if you just want to print something out to the screen, this is exactly how you would do it. Print and then whichever column you want or whichever field you wanted to print. So let's move on and talk about the device logon events table. So the device logon events table, in fact, let me go ahead and do this first here. Take 100 of these. So the device logon events table is going to contain one row for each logon made to a device. And this is based on Defender ATP. So this is going to include local logons, network logons, successes and failures, everything. You're going to get a bunch of information about the account that tried to log on, the protocol that they were using, the process that fielded it. So in this case, when you're using device logon events, the actual process that's fielding the logon is going to be the initiating process in this case. So it's going to let you know which process is performing the logon essentially. So there's a bunch of good information here. You'll also get some network information if it's not a local logon. There's also a field in here which I find rather handy, which is local admin. So if this is set to 1, the account, when authenticated, was resolved to be a local administrator of that particular device. Now, the other operator we have here is count. Now, count is a handy little command if you want to try and figure out how big of a result you're going to get back from your query. So in this case, if I just ran this without the pipe count on it, I would get 27,400 rows back, at least at the current moment. Keep in mind, rows are constantly being added, and they're also being deleted when they hit their lifespan. And actually, a very important note when it comes to lifespans. So there's different types of data lifespans you're going to have inside the system. So there's the overall retention policy that's going to be configured underneath if you want under settings. There's a section where you can set the data retention, which can be up to 180 days. When you're querying data in advanced hunting, you can only get back for 30 days. This is for performance reasons. So moving forward, we're going to take a look at the app file events table. So app file events is going to be any information that regards to files that are stored in a cloud service. You're going to see, for example, in this case, we've got some OneDrive for Business. This is the actual file name and the full file path here. This is coming essentially from MCAS, or Microsoft Cloud App Security. You can also see, depending on the type of access, in this case, they don't have many, there we go. So you can see, for example, the IP address, the geolocation of the IP address, and the ISP that was used to perform that access. So in this case, we can see Barbara Moreland here is accessing things inside the accounting files folder on what appears to be her corporate OneDrive. Now, once again, you notice it said take 100 to limit the results, and I sorted the results based on timestamps. So sort is something you're going to use a lot, especially when you're dealing with chronology like timestamps. So in this case, we're doing this in descending order. So everything in here should be sorted automatically in descending order. That said, you don't always have to, you can actually sort after the fact if you're using the web interface. So for example, I can click on this little column here and switch the sort order. You can do that with any of the columns that are available, not just timestamp. But sort is going to be something you're going to use a lot during when you're hunting through your environment, and especially if you're trying to figure out what happened just before or just after an event, or maybe you want to see, maybe you're using some summarization and you want to highlight the most common or the most rare aspect of your query. So for our SQL people in the world, this is sort of like doing this. In this case, we did select top 100 star from device file events, and we're doing an order by timestamp descending. This is essentially the SQL equivalent of this here. As a side note, there is also I believe there's actually a SQL to KQL cheat sheet that's out there for those SQL admins who are trying to learn Kql query language. Moving along, we're going to talk a bit about the device registry events. So device registry events are going to be any changes made to the registry of a device monitored by Defender ATP. In this case, we're going to see notice I mentioned changes. Reads are not included in this. If we started recording reads, it would just be too much volume for us, honestly. So, but if you look, you've got registry deletions, sets, creations. You can see the actual registry value type that came up, the name, the data, and you can actually see if it was a change, you can see what the previous values were. You'll also see, once again, the process and the identity which performed the change. Now, in this case, I'm using an operator called top. So in this case, it's sort of like we did a sort and a take, if you will. So in this case, I'm going to get the top 100 results based on timestamp and descending orders. This is the 100 most recent rows from the device registry events based on timestamp. Another thing that's very handy if you're trying to filter through a bunch of quantified data. So once again, the SQL equivalent would look something like this: select top 100 star from device registry events. We're ordering by timestamp and descending order. Moving forward, let's take a look at the device network events. Before I run this, let me go ahead and just show you what's inside device network events. So device network events are going to be any inbound, outbound, successful, or failed network connections made by a device monitored by Defender ATP. You'll see the local IP and the remote IP. Notice it's not source and destination necessarily, because we're looking at it from the perspective of the device. So the local IP will be the IP of the device that's performing the network communication, and the remote IP is going to be the IP it connected to. You'll also, once again, have all the process information and the identity, but the network-specific information includes remote URL. You'll be able to see a remote port, the protocol that was used. We also have, and this can be really handy when you're trying to filter through your data, the local IP type and the remote IP type. So you'll see public and private in here. There's a bunch of information. And as a note, you can actually click on any of these links and it will bring you to a page. So for example, if I was to click on this, it's going to bring you into the Defender ATP page on that particular file hash. Same thing works with IP addresses. So if I wanted to analyze a specific IP address, I can click on the IP address, and as long as it's got a link there, and it'll bring you to a page on that particular IP address. And actually, as just popped out on the right here, so if you click on one of the rows, you'll get this really great view of how the actual process was launched. So in this case, you can see we had a process ID of 1864, which launched np command run, which then again launched np command run. So even if, as long as the data is here to support it in your query, it will build this nice little view for you to see exactly what happened in this case. So we can see the command line of that process, and these are expandable as well. You can dig in to the initiating process information. So really handy when you're trying to get a deep dive into what exactly is going on. Now, you'll notice I have a field here called distinct. So the distinct operator is going to take the list of columns that you specify, in this case, remote IP and remote URL, and it's going to get distinct pairings from that. So you notice I said to take 1,000, but I got 529 results back. That's because there's a bunch of duplicates inside that data set. So here we've got, for each IP and URL pair, you should have a single row. Notice in this case, it looks like we have two different IPs for the same URL. So you will see what appears to be a duplicate in some cases, but it's going to be dependent on the duplication is essentially the pairing of the columns themselves. So in SQL world, it's sort of like saying select distinct remote IP, remote URL from device network events. The same exact concept, if you would. Now, project. So project is a really handy one. In fact, before we get into project itself, I'll show you what device info is. So device info, whenever a Defender ATP monitored endpoint checks in with Defender ATP, we're going to have this report, if you will, that's going to give you information about the operating system, the public IP address. So what IP, if it went to the internet, what IP would we expect it to have? It's going to have the information about the client version for the Defender ATP client on it, as well as information about who is logged on, the device's object ID, a bunch of good information in there. So this is where I typically go if I want to try and find out what operating system or what public IP address a device has. We'll talk a bit more about this one in our later summarizing and pivoting chapter on how to really maximize the results here. Now, project. So what project does is it's going to strip away all of the columns that are not in this specific list. So in this case, you're going to see we had a bunch of columns, but now we only have device ID, device name, OS platform. We are not deduplicating anything in this case. We're just removing the columns. There's other things you can do as well with project. So you can actually rename a column if you want. So let's say you don't want OS platform to be OS platform, you want it to be OS instead. You can actually type OS equals, and it will change the column name into OS. The other thing you can do is you can actually create a calculated column. So unfortunately, at this moment, this is going to be something you're going to use a lot more when we start talking about the summarizing and the pivoting aspect of it. But to kind of show you how it works, we'll go ahead and create an example here where we grab device info. We're going to use project to get a timestamp, the device name, and then we're going to create a column called 4. And that's going to be the equivalent of 2 plus 2. And as you can see, 2 plus 2 consistently equals 4 in each one of these results. Now, project is sort of like this portion of the select statement, if you will, the select section, because this is going to be what columns you bring back and any aggregations you want to perform on that particular data. So moving forward, so we'll talk about the device network info table. So device network info is the local networking information from the device. You don't have to make a network connection for this. It's going to show you all the different IP addresses associated. You're going to see we've got the device, the network adapter name, the MAC address for that particular network adapter, which networks it's connected to, the DNS configuration, which can be really handy for troubleshooting. As well, you're going to see in this case, we've got DHCP address on there, and then this JSON field, which you can actually parse out if you want to report on it. Now, what we're going to talk about here, though, is the project away operator. So let's say for some reason we don't like the timestamp. So project away is the exact opposite of project, where it just removes whichever columns you specified in that list. So in this case, you'll notice we no longer have our timestamps here on the left. There's a couple of other ones which are pretty handy. So the project reorder is one that you'll see we'll be using a little bit later on. Project reorder is basically, it doesn't change the data itself. It just changes the order of the columns that come back. So for example, if I wanted to highlight the IP address, I can make that move all the way to the left. We have an example that's a little bit later on in the demo. There's also project rename. So project rename is just going to rename a specific column. So if I didn't want to use project and have to specify every single column in the data set that I want to come back, I can just say project rename, specify the new name equals the old name for the column. So device image load events. Now this one is where our cyber guys are gonna kind of light up a bit. So this table is every library that's loaded up by an executable monitored by Defender ATP. This is your DLL side loading type detections, if you will. And what you'll see is you're going to see in this case we've got, so you'll see our device ID, of course, the library that was loaded into memory. In this case, we're seeing image loaded. Let me close this out here. As well as over here to the right, the initiating process information that performed that load. So pretty handy if you're trying to see if, for example, A library is commonly in one location, but in some cases, it ends up in a different location, which might be evidence of suspicious activity. So let's talk a bit about, in fact, we're going to use project reorder here to highlight how this works. So let's use the extend operator now. So what extend is going to do is it's going to add a column to your data set. So in this case, we're going to create a column called domain and user, and it's going to be the equivalent of a string concatenation of the column initiating process account domain, a backslash, and the initiating process account name. Now you'll notice the backslash looks a little bit funny. So backslash is the escape character for strings in KQL. So there's two different ways you can do this. You can use double backslash, or you can actually put an @ sign before it. We'll show you in just a moment. Now the next thing I want to talk about here is the string concatenation. This is essentially an array of columns or values that you want to concatenate together. Basically, it's sort of like doing a string add, if you would. And the last thing is our project reorder. And you'll notice in the results, domain and user is all the way to the left. Typically, when you use the extend operator, what happens is the column gets added all the way onto the right of the data set. In this case, we want to see the domain and user, so we moved it all the way over to the left. We also prioritize the initiating process account domain and the initiating process account name, so you can see that it's lined up. So the next one we've got here, let's talk about app file events. And we're gonna so bring this one up here. So in this case, what we're going to do is we're going to use the timestamp column, and we're going to compare it to 3 days ago. So the ago operator we've got here is really handy when you're trying to do time-based filters and not lock it into a specific date. So what this will do is this is going to say take the current date timestamp and go 3 days back. Now this can be 3 days. You can do 3 minutes with this if you wanted to, or you can do 3 hours. There's a bunch of different types of filters you can apply here. The resolution in Kusto goes all the way down to 100 ticks. That said, I don't think we'll be analyzing anything that's quite that fast in most of the time in Defender ATP or in MTP. So in this case, we use the where statement. This is the first time we've gone over this one. So this is just like in the SQL where the where clause inside of a SQL query, if you would. It's essentially a Boolean. So we want to be able to pass a Boolean statement back. So in this case, it's going to be a pass or a fail whether or not the timestamp from app file events was greater than 3 hours ago, or originally was 3 days ago, or not. So where is going to be something you use quite a bit. Now in KQL, we use the deformable Boolean logic types here. So you see the double equals. Single equals is essentially you're trying to set a value, a column to a value. Double equals is you're trying to compare the two values. So as I mentioned before, the most effective way to improve query performance in KQL is to filter it based on time and reduce things based on time. Ideally, if possible, more recent events. Now, as I mentioned, so by default, Kusto is a case-sensitive language. So you'll see if I try to compare test to test with the double equals operator, I'm getting back that it's not equal. So there are case-insensitive operators for many, if not all, the different comparison operators you have here. So for a case-insensitive comparison, you're going to use equals with a tilde operator here. Many times in our query language, if you see the tilde, you're forcing something to be case-insensitive. And as you can see now, is equal is set to 1 or essentially true. Now there's a bunch of different operators here, and we'll be using these throughout the series. I would recommend if you have an MTP instance to use, I would recommend diving in and trying some of these out, getting familiarized with them. You'll notice that many of them have a case-sensitive and a case-insensitive operator. There's also a great if you follow the link that I've got in this CSL file here, you have the official reference for each of these operators. But it should look pretty familiar. It's a lot like if you use .NET. So you've got, for example, contains. This is a substring search by default, case insensitive, unless you put a _CS at the end of it. There's starts with, which searches the prefix of the string, ends with, which searches the suffix of the string, and there's not versions of both as well. There's also, for example, has. So this is going to look for a whole word. This is really handy when you're looking at command lines. So if you want to see something space on both sides of the term, has is the way to do that. You can also do that in a case-sensitive fashion, depending on what you're looking for, if you're looking for a specific case inside the term. So let's go ahead and use a couple of these operators here. So the first one here is going to be in. So in is going to compare a term against a list of terms in this case. Now you'll see, is it equal came back false, right? We did the quick brown fox and we searched for quick. That's because by default, in is case sensitive. If we want a case insensitive search, put the tilde at the end of it and do a search, and it's going to come back, is it equal, is true. Another one we've got, so has can be used to search an array term as well. Lorem ipsum dolor does have dolor. So so has by default is a case sensitive operator. You can also do a case insensitive operator if you want, as well. Pardon me, a case sensitive operator as well. And again, so if we do Microsoft, does it contain ICR? In this case, it does not, because we're using contains with CS. So if you get rid of that, it becomes a case insensitive operator, and you'll see it comes back as it is equal. So as I mentioned, I would definitely recommend going to this URL and checking out some of the operators. There's a bunch of really, if you're one of those, if you like pain like myself here, matches Regex is available as well. So we do support Regex search. So that'll enable you pretty much the full Regex language to do string comparisons. So characters and escaping. So as I mentioned before, the backslash is an escape character. So if you want to use a backslash, you have two ways to do it. The first way is the double backslash. The second way is if you put a at the beginning here. Now an at is essentially a string literal. So it's going to say, take the string as it is, don't do any don't do any substitutions with the escape character. As you can see, it comes back. This example uses a string literal method with single slashes as we would expect. Now, null or blank values. So you've got a couple options here. So is null and is not null. We'll compare a column against null itself. So this is essentially like saying here, for example, SQL equivalent will be select the time generated event data from security event where the event data is not null. That would be checking if it's not there at all. Now, this is an important note. Is null is great, but if I run this command here, you're going to see that an empty string is not null. So to get your empty strings in there, there's a separate operator, and this is what I'd recommend using if possible, which is the is empty or is not empty operators. This will check for an empty string or null. So for example, this is like saying in SQL, select time generated event data from security event, where event data is like %. So basically it has something in the string. So if we want to see identity query events where is not empty account SID and take 100 of those, we're going to be able to get those empty strings in there, get rid of those empty strings. So identity query events. This is going to contain a bunch of query events performed against Active Directory objects such as users, groups, devices, or domains that are monitored by Azure ATP. This is really handy when you want to look at DNS data, by the way. Let's see if we have any DNS data that came back in this case. Not in this particular query here, but we can see SAMR enumerations, if you will, as well as LDAP. That's done. So this is primarily your on-premise Active Directory monitored by Azure Active Directory, Azure ATP. Now this last operator here is really super handy. So search. What search is going to do is it's going to search all rows, all columns, substring, case insensitive for whatever you specify. So in this case, I searched for Microsoft.com, and you'll see we've got a whole bunch of URLs that came back. Now, in this case, you'll see these all should have Microsoft.com, and it looks like we got only network events in this particular case. Now, when you use the search operator, you're going to get another column here called $table. This is going to tell you which table the actual row came back from. So in this case, these all came to the device network events table. Now, if you have results that come from multiple tables, what you'll see is your columns you have here will be a unioned together set. So wherever the column name and data type matches, it's going to merge that column. So all device IDs, if the table has device ID for that row, you will be inside device ID. But you also see over here to the right, in this case, we only have our device network events. Let me use a different one of our options to show you that. As it goes through the tables, additional columns be added over on the right-hand side. So sometimes the column you would normally expect to be up front and center may be pushed off to the right because the order that it did the search in eventually put it added the columns to the far right hand, the end of the query, if you would. There's not really a true SQL equivalent that I'm aware of for this, other than searching an index or unioning every single table and column together and searching that, which is not what you really want to do. Now, you don't have to use search just like this. Now, this is a rather inefficient way, to search for something. Like in this case, let's say I wanted to find administrator. I'm gonna get tables from all over the place, but I can actually use search like this as well. So as an operator. So in this case, I'm gonna tell it I only want to search in the identity info table for the string administrator. And every row in here should have administrator somewhere in it. So you see we have some surnames here. We've got, let's see, so network administrator, database administrator came back. Let me see here. So every row here should have the word administrator somewhere in it as in the substring capacity. Now, identity info. So this table is essentially a picture of your Azure Active Directory. So this is great for correlating the account object ID, or if you have a user principal name, and associating that with your data set. You'll see, especially in our 4th episode, we use the account object ID a lot. If possible, this is probably the best way to correlate your accounts inside of MTP. But that said, you absolutely can use user principal names or SAM account names, if you will. So our last one here, so I want to talk a bit about using Boolean phrases. So if you run this, what you're going to get back is any row that has both administrator and CMD. It doesn't have to be the same cell. It has to be the same row. So this is kind of handy if you want to filter back your data set. Each of these should have the letter CMD in it, as well as administrator somewhere in here. So we've got, let's see, so this one's in the folder path. We've got some conhost over here. So I'm sure this is probably CMD being run by administrator in this case. Let's see. Yep. So there's in the actually initiating process had administrator in this particular case, and it was CMD that launched it. So really handy if you want to try and get a more accurate result. So search with Boolean operators is the way to get to accomplish that. All right. So let me go ahead and bring back up our slide deck here. So any questions on that we wanted to, Valan, do you want to cover any questions we want to highlight?
Hi, Michael. Yes, first of all, can you share the slide? I'm not seeing it yet.
Yes, hang on one second. I was going to share the query window in case one of the questions required a query.
Oh, okay. One of the main questions that's coming up, and it was already answered, but would like to hear your take on it. The folks are wondering, what is the difference between MTP and the Defender? If you can elaborate on that.
Absolutely. So MTP and Defender ATP are, so essentially Microsoft Threat Protection, or MTP, is taking your Defender ATP, your Office ATP, your Azure ATP, and your MCAS data and linking it all together. So I'm going to jump out of advanced hunting here for a second to show you a couple examples. But what you're going to get is incidents and alerts that come from all of those and are correlated aggregately across all the different data sets. So you'll see in here, we're going to have some MCAS alerts. We're going to see antivirus alerts, EDRs. These are Defender ATP detections, if you will, as well as you're going to see these really neat MTP alerts, which, so for example, if we identify a credential stolen and we see a suspicious logon, because we can see across Azure ATP and Defender ATP, we can correlate those data sets. Now, Defender ATP is specifically looking at the devices themselves. So from a process launch perspective, from an anti-malware perspective, but ultimately that the alerts from there get fed into MTP and can be correlated with other sources if you have them as well. So you'll see sometimes if there's a phishing email that's detected after the fact, or maybe specifically a piece of malware that maybe wasn't detected initially, but is detected after the fact by Office ATP, we can correlate that with where it's been seen on devices inside MTP. It gives you that broader picture.
Thank you, Michael, for that. There's a question, you were sharing a Kql query earlier, and the ask is, how do we know what are the parameters that can be passed in place of Defender? Alternate information where definition source contains quoted Defender.
Okay, so let's I'd have to see, let me take a look at the question itself so I know which row and column. So I'll show you a way to get this. I'm trying to think of which one would be let's do device network event. So if you remember, we had that distinct operator. So let's say, for example, I want to know the different types of, what's a good one? Actually, let's do device logons. So probably even a little better than this one here. Device logon events. And we'll use logon type. So for example, let's say I wanted to know what types of logons are available. Device logon events. You can actually go in here and do distinct logon type. And this will let you know, based in your data set within this time window, what different types of logons are available. So these are the different terms. Now, that said, there's also a schema reference, as I mentioned up here. So we can also jump into here. So for example, device logon events. You have a full documentation of a lot of this, as well as you can click on this link here and it'll bring you out to a web page that will break it down even further into all the available fields and types that are out there.
Okay, great. Thank you for that. So it seems like the I guess the KQL queries, there were questions about if the MTP queries are supported in Sentinel, and that's something in the works, looks like. So what about the alarms? Do they go to Sentinel with connectors?
So at the moment, you can set it up to consume alerts and instance. Actually, Tali would probably be better to speak on this one.
Yeah, thank you, Michael. So today you can connect the alerts coming from the different products into Sentinel by the single connectors of the different products. For example, for Azure ATP, you have a connector. For Cloud App Security, you have a connector, and you can connect the different connectors into Sentinel, and you will get the alerts from there. And as we just said, today it's not possible to get the raw data and the alerts from MTP into Sentinel. This is something we are working on.
Okay, and yeah, in relation to that, and perhaps, so there's another one, it's asking, why are we not able to export alerts from the alerts incident page? Can it be fetched using advanced hunting query?
Yes, so this is something we actually will go into in a couple later episodes. So you have two tables here, alert info and alert evidence. So alert info is essentially your alert, your MTP alerts. So we take 100 of these. What you're going to see is this is the human readable form, if you will, of alerts. And now the actual underlying data associated with it is going to be in a table called alert evidence. So alert evidence is going to contain the individual detection. So for example, the device or the user account or the file hash or whatnot, or the IP address that's associated with the alert, and it's correlated together by the alert ID. So this is something, so we'll be talking about joins in the next episode. This is where this would come in handy, is you'd essentially take your alert info, let's see if we do this here, for example, info, take two of these, and you could do a join on alert evidence, on alert ID. And essentially what this will do is I'm going to take 2 at random alerts from this list and join it together with its alert evidence. And you'll see that you'll see multiple representations of each alert ID as a result of this. But you'll see, for example, we have a possible travel, and we have it associated with these 2 different remote IPs and this particular user account. But this is something we'll be covering joins extensively in the next episode.
Got it. Thank you. Let's see. What about reverse? Can you send Sentinel output to MTP? Is that supported?
We don't have.
No.
Yeah, go ahead, Tali.
It is not supported at the moment. We are working to sync the 2 products. The data will be available in both of them and will be synced by status, by the data itself, by the schema, and so on.
Perfect. Thank you, Tali. Is there a mechanism to create a custom detection using the advanced hunting query itself?
Yes. So this is something we're going over in episode 4. But essentially, if you have a query, we do device process events. Just take one of these. And to do this, I'm going to have to clear out this rest of this query to make this work. There's a create detection rule button over here on the right, which we'll go over this and talk about this during episode 4. But this lets you take any query you want and create an alert based on it. And then you can actually create automatic responses based on it. And you can constrain those responses to device groups if you'd like. So that's something we'll cover. Definitely stay tuned in episode 4, because that's where we're going to really get into the hunting side of it.
Well, sounds good. I'll go ahead and cover some reminders before we close the call. So as Michael shared earlier in the call, there's 3 more episodes for the series. And the next one is, we're doing it on Wednesday. So the next one is on July 22nd. And then we also have on the 28th, so this is Azure Sentinel. Seems like we're all in a KQL world here. So Ofer will share with us KQL hands-on labs exercise. So that is for the Sentinel site on July 28th. And then we continue on with the back-to-back episodes. So just to remind you, as we have the slides put out there, on the 29th, that's the 3rd episode, we'll go over summarizing, pivoting, and visualizing data. And then on the last episode, we'll go hunting and learning how to apply KQL incident tracking. We also have Azure Sentinel coming up. We have on August 12th, we have threat hunting and dwell time reduction. And then on August 19th, we have threat intelligence automation with Risk IQ. And we have September 2nd, Azure Sentinel log forwarder deep dive. This is filtering Ceph and syslog events. And then September 9, also Azure Sentinel optimizing Azure Sentinel KQL queries performance. Now, for all this, you can register by going to aka.ms/security webinars. In case we missed to answer your question, or if you have additional questions, you can visit us on the Microsoft Threat Protection Forum at aka.ms/mtptc. All the links mentioned here, they're shared in the chat room there. And I would like to close this webinar by thanking Michael for a great presentation. Thank you to the rest of the team who helped answering the questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.